Dousing ourselves inside the perpetuation of the universe, we people have ceaselessly examined the danger of whether we unquestionably are the main species to have a planet, looking on the stars, thinking about distant universes, and examining the limit with respect to life beyond our little blue planet. That capacity has finally arisen. NASA's boss has truly expressed that the James Webb Space Telescope has caught something brilliant near the precarious edge of our enormous neighborhood. The James Webb Telescope has no gouge on Proxima B, the closest, most logical, livable exoplanet to Earth. We evaluated that an expected city made through sharp living things was recognized, which up until this point, we don't have any clue about. The new James Webb discovery proposes how the wonder of the phony lighting of the town of Proxima B has worked on in addition to the synthetic mixture of the climate of this exoplanet, which has been not entirely settled. So, go along with us on this high-quality outing to Proxima B to track down the nuances of this exposure. As demonstrated by NASA's boss, the James Webb Telescope might have used this development and has found evidence of life on Proxima B, an exoplanet found simply 4.24 light-years from our solar system. Proxima B has turned into a subject of interest because of its potential to be habitable. This exoplanet circles its parent star, Proxima Centauri, a red dwarf that is significantly more unassuming and cooler than our Sun. Situated in 2016, Proxima exists in the star's habitable zone, also called the Goldilocks zone, which is the district around the star where conditions could grant the presence of fluid water, a pivotal component for life as we know it. Proxima B's closeness to Earth and its location in the habitable zone have generated significant interest and hypothesis about its capability to support life. However, it is essential to understand that the habitability of an exoplanet is a complicated riddle involving various factors. Proxima B is described as an exoplanet with a mass around 1.3 times that of Earth and has an orbital period of roughly 11.2 Earth days, implying that it completes one circle around Proxima Centauri in that time. However, things aren't quite so clear as we would normally expect. The fact that the planet is Earth-like in size and orbits a red star doesn't ensure that it is an ideal imitation of our planet and that we can all move there. The habitability of Proxima B is still up in the air by different factors, one of them being the planet's atmosphere, which acts as a protective shield and plays a crucial role in regulating temperature and supporting life. Also, the specific composition of Proxima B's atmosphere is still dubious, making it hard to determine its potential livability. Scientists are working on methods to study the atmosphere of Proxima B, and a key tool in this work is the James Webb Space Telescope. This telescope will allow analysts to investigate the light that passes through the exoplanet's atmosphere during transit, providing them with data about spectral elements and helping them look for potential biomarker molecules that could indicate the presence of life. Another critical factor affecting habitability is the presence of water. In addition to Proxima B being in the habitable zone, it is crucial to determine whether it has a sufficient amount of water to be considered suitable for life. Water is a major piece of the puzzle, and analysts are searching for indications of liquid water on the planet's surface, whether in oceans, lakes, or streams. These bits of information are vital for assessing the likelihood of habitability on Proxima B. The presence of water in different states, like ice or vapor, is also considered, as water availability is essential for supporting biological processes and is viewed as a key marker of habitability. The atmosphere of Proxima B raises concerns about its conditions. Scientists must also investigate factors like temperature, pressure, and geological activity on Proxima B to assess whether the planet is within a viable range for life to thrive. Extreme conditions, such as scorching heat or extreme cold, can make survival challenging. Stability is also significant. Volcanic eruptions or seismic activity can disturb livability. However, stability is uncertain, as Proxima B is believed to be in a tidally locked state, meaning that one side of the planet remains forever in darkness, while the other side is constantly illuminated by the star. The extreme temperature variations between the illuminated and dark sides may influence the planet's habitability. These are just a few considerations that scientists are analyzing in the search for habitable planets. Researchers are studying the chemical composition of Proxima B to check for the presence of organic molecules like amino acids and other compounds necessary for life. They will also focus on whether the planet receives enough energy from the star or other sources to fuel biological processes and allow life forms to flourish. Despite all these studies, the question remains whether Proxima B indeed has all the necessary components to be considered a habitable planet. Is there significant evidence for this? The discovery of Proxima B in 2016 was a remarkable achievement. Astronomers used a high-precision instrument called the High-Accuracy Radial Velocity Planet Searcher, or HARPS, to detect the subtle gravitational pull of an exoplanet around Proxima Centauri, our nearest neighboring star. This high-precision spectrograph is designed specifically to detect exoplanets and works at the La Silla Observatory in Chile. It has been crucial in the discovery of several exoplanets, including Proxima B. The HARPS instrument works using the radial velocity method, also known as the Doppler spectroscopy method. Its capability is to detect exoplanets by measuring the subtle changes in the host star's spectrum caused by the gravitational pull of an orbiting planet. These movements, called radial velocity or Doppler effect, occur due to the slight wobble of the star as it's pulled by the gravitational interaction with its companion planet. HARPS has an optical fiber that collects light from the target star and directs it to the internal spectrograph. In the spectrograph, the light is dispersed into its various frequencies, allowing astronomers to examine the star's spectrum in detail. This enables scientists to determine the star's radial velocity with great accuracy. To achieve the high level of precision required for exoplanet detection, HARPS uses specialized techniques. Trend-setting innovations and strategies that incorporate a temperature-controlled climate to balance out the instrument. Furthermore, measures to restrict the impacts of different factors that could ruin exact estimations. What is your take about Proxima B? Do you accept it as tenable, and that later on we might actually move to this wonderful exoplanet? Let us know in the remarks. Gratitude for watching the video. Make a point to like and subscribe, and I'll see you in the next one. NASA's Explorer 1 test, the most far-off human-made object in the universe, is sending usable information back to Earth again. In the immense universe, we have no clue about what it is, except for we can measure it. Explorer 1, the famous space test sent off by NASA over 4.5 many years ago, has quite recently conveyed back a message that has sent shock waves through the academic community. In the wake of voyaging almost 14 billion miles from Earth, Explorer 1 has made a revelation so significant that it has changed the direction of its mission, moving back in the direction of our planet. But what precisely could this revelation be? Might it at some point be proof of extraterrestrial life, an infinite irregularity, or then again something considerably more unfathomable? In this grasping investigation, we divulge these shocking disclosures, as Explorer 1 just made a frightening discovery that made it unexpectedly move back in the direction of Earth. History tells us that the Explorer twin tests, if certain heavenly events hadn't matched, two of the most remarkable shuttles ever sent off may very well never have left Earth. In this situation, it were the four largest aligned stars and planets in our planetary group around 60 years ago. These planets were slowly aligning in a manner that had last happened during Thomas Jefferson's administration in the mid-19th century. This rare planetary arrangement went to a great extent unnoticed at first. The first person to recognize its significance was Gary Flandreau, a doctoral student in aerospace at the California Institute of Technology back in 1965, when space exploration was just beginning. Working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, Flandreau was tasked with sorting out the most efficient method for sending a space probe to Jupiter and, even further away, to Saturn, Uranus, or Neptune. Using a simple pencil, he meticulously plotted the orbital paths of these giant planets and made an intriguing discovery. In the late 1970s and early 1980s, all four planets would align in such a way that they could be visited in a single mission. This arrangement meant that a spacecraft could use the gravitational pull of each planet to slingshot itself to the next, altogether reducing travel time. Flandreau determined that this alignment would reduce the flight time from Earth to Neptune from 30 years to only 12 years. However, there was a catch: this planetary alignment only happened once every 176 years. To take advantage of this rare opportunity, a spacecraft would need to be launched by the mid-1970s. NASA seized this once-in-a-lifetime opportunity and built two spacecraft to make the journey, Explorer 1 and Explorer 2. They were sent on a remarkable mission to explore the outer planets of our solar system. Because of the alignment of the planets and the visionary calculations of Gary Flandreau, the launch of the Explorer twin probes on September 5, 1977, marked something truly extraordinary, at a site called Cape Canaveral in Florida. Explorer 1 set out on its epic journey into space, launched by a powerful rocket known as Titan 3E or Centaur, only 15 days after Explorer 2 was launched on August 20, 1977. Explorer 1 joined the infinite adventure, starting its journey into the vast universe by following a shorter route. Their primary mission was to explore the massive gas giants in our local planetary system, including Jupiter and Saturn, along with their various moons. However, these brave space voyagers exceeded all expectations. They ventured far beyond, pushing the limits of exploration, traveling farther and longer than any other spacecraft in history. They broke numerous records on their awe-inspiring odyssey. They have traveled farther than anything ever made by humans, even venturing into a region known as interstellar space, an unfamiliar region within our system. These exploratory spacecraft, Explorer 1 and Explorer 2, are now more than 12 billion miles from us. Despite their immense distance, they continue to astound researchers with the astonishing discoveries they make out there. Most recently, they have made a revelation so unexpected that it has taken everyone by surprise. The Explorer twin probes have achieved some truly extraordinary accomplishments. Many years ago, they explored the moons of Jupiter and Saturn, revealing worlds more beautiful than scientists had originally believed. Researchers initially thought these moons were dull and pitted, like our moon, but they turned out to be stunningly complex. Explorer 1 reached Jupiter in March 1979, just 546 days after its launch. Explorer 2, following a slightly different course, arrived in July of that same year. Both spacecraft were equipped with VidCon cameras that used filters to capture full-color images. Interestingly, they were designed to be extremely steady, rotating through space at a rate more than 60 times slower than the hour hand of a clock. This ensured that the images they captured were clear and sharp. During their mission, the probes took over 33,000 photographs of Jupiter and its moons, each revealing new and stunning details. For example, Europa, one of Jupiter's 53 named moons, was found to have a cracked icy surface, estimated to be over 60 meters thick. As the spacecraft left the Jupiter system, they received a speed boost of 35,700 miles per hour from a gravitational slingshot, a pivotal move that helped them head toward interstellar space. At Saturn, the explorers went their separate ways. Explorer 1 passed through Saturn's magnificent rings, enduring countless impacts from tiny dust particles, before passing by Titan, a moon surrounded in an orange haze, and heading north out of the plane of planets. Explorer 2 continued its solitary journey, eventually reaching Uranus. Neptune, in 1986, during its visit to Uranus, Explorer 2 found 10 new moons and added the planet to the rundown of universes in our planetary group with rings. Anyway, Explorer 2's accomplishments were eclipsed by misfortune when, only 4 days after its nearest approach to Uranus, the Space Shuttle Challenger unfortunately detonated not long after takeoff, claiming the lives of each of the 7 crew members, including Krista McAuliffe, a secondary teacher from New Hampshire who was set to become the first civilian to go into space. After 3 years, as Explorer 2 flew about 2,800 miles over Neptune's shocking purplish-blue methane sky, it experienced the fastest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, turned out to be an unusual world with springs regurgitating nitrogen into space. Explorer 2 captured the astounding scene in a series of close-up pictures. Following its visit to Neptune, Explorer 2 joined its sister probe, Explorer 1, on an epic journey into interstellar space. As they wandered further into the unknown, the explorers experienced a mysterious limit known as the heliopause, where the influence of the Sun gives way to the vast territory of interstellar space. Explorer 1 crossed this limit on August 25, 2012, becoming the first human-made object to enter interstellar space. Meanwhile, Explorer 2 continued in its strides, crossing the heliopause on November 5, 2018. As they continue their journey into the unknown, the Explorer spacecraft carry with them a golden record containing sounds and images that depict the variety of life and culture on our planet. This infinite time capsule, made by a team led by astronomer Carl Sagan, is intended to act as a message to any extraterrestrial beings who may one day encounter the spacecraft. This golden record, a testament to humankind's quest for knowledge and connection with the universe, contains a diverse collection of Earth's natural sounds, greetings in 55 different languages, a selection of music from various cultures and eras, and 115 images depicting life on Earth. The hope is that, even after billions of years, some intelligent civilization might accidentally discover these records and gain insight into the existence and culture of humans. As Explorer 1 and Explorer 2 continue their extraordinary journey, they send back data that continually advances our understanding of the universe. One of the most significant and ongoing discoveries made by Explorer 1 was the detection of a persistent hum of interstellar gas, a faint plasma wave emission in the interstellar medium, which provides valuable insights into the density of space between stars. This discovery is crucial for understanding the environment beyond our solar system, offering clues about the nature and distribution of matter in the galaxy. Furthermore, both spacecraft have provided significant data about cosmic rays, magnetic fields, and the heliosphere, the vast bubble of space dominated by the solar wind emitted by the Sun. By crossing the heliopause, the explorers have given scientists a unique opportunity to study the interaction between our solar wind and the interstellar medium, helping to improve our understanding of space weather and its potential effects on Earth. In their extended mission, the explorers have faced and overcome various technical challenges. They are powered by radioisotope thermoelectric generators, RTGs, which convert the heat released by the decay of plutonium-238 into electricity. As the plutonium-238 decays, the power output of the RTGs gradually decreases. Despite this progressive decay, the spacecraft are expected to continue operating and sending back data until around 2025, when their power levels will drop too low to support any scientific instruments. In their twilight years, the explorers have become senior statesmen of space exploration, inspiring new generations of scientists and engineers. They represent the spirit of discovery and the human drive to explore the unknown. Their journey, which began over 40 years ago, continues to captivate the imagination of people around the world, reminding us of the vast possibilities that lie beyond our home planet. The dazzling discovery of artificial light detected on Proxima B, combined with the possibility of an atmosphere capable of supporting life, has reignited interest in the search for extraterrestrial intelligence, SETI. This discovery, facilitated by the James Webb Space Telescope, opens new avenues for exploring the universe and seeking answers to the age-old question, are we alone in the universe? Proxima B, with its potential for habitability, serves as an encouraging sign and piques interest as we delve deeper into the mysteries of this distant exoplanet. We are reminded of the importance of continued curiosity in space exploration and innovation. The advancements made by the James Webb Space Telescope and the groundbreaking work of the Voyager probes highlight the transformative power of scientific inquiry and the quest for knowledge. In the end, the discoveries made by Explorer 1, Explorer 2, and the James Webb Space Telescope represent monumental achievements in humanity's history. They underscore our capacity for innovation and our unwavering desire to explore the unknown. As we continue to push the boundaries of space exploration, we look forward to the day when we can finally answer the profound question of whether life exists beyond Earth. Until then, the explorers and the James Webb Space Telescope will remain our eyes and ears in the vast expanse of the universe, guiding us toward new horizons and deeper understanding.